Hello, pre-calculus students. Today we are going to be talking about section 9.2, which is graphing, graphs of polar equations. So you'll need pencils, highlighters, your notes. You will also need a graphing calculator today, or Desmos on a computer or the app on your phone. Okay, you need to do this as we're going through it, otherwise it will make no sense. Okay, so in your notes, here's this table of all the cool different graphs that you get when you graph a polar equation. So you can get a rose shape. We'll talk a little bit about how you can tell how many petals there will be. Okay, if there's a cosine or a sine, it will change the symmetry that your graph will have. You can have a lemniscate, which is a figure 8 shape. A limosine and cardioid, if you look at the forms for those equations, you'll see that they're pretty similar, right? In this one, the numbers in front are the same. In this one, they're different. Some of them have a little loop. Again, whether it's a cosine or a sine will impact the symmetry, right? Cosine things, think about how it's like cosine is x, like horizontal, sine is y, vertical. And then we have something called the spiral of Archimedes. So these are the different forms of the equations. You don't necessarily have to memorize them, but sometimes knowing them will help you to know what to expect. We're going to use the calculator to graph these. And if you don't have a graphing calculator, that's fine. You can use Desmos. I'll show both ways. So for the first one, when we look at that equation, we should expect the shape to be a rose. Both of these are going to be rose shaped. And I'll show you both ways how to put it into the calculator and also how to put it into Desmos. So in the calculator, the first thing you want to do is in settings, let me see this. You want to make sure you're in degrees. I want to get it on here somewhere where you can see it and the glare isn't completely horrible. Okay, so I am in degrees. You do want to make sure you're in degrees. Make that your default if you haven't already. And then I'm going to open a new document. Okay, so I'm going to go to 1 to open a new document. I'm going to choose 2. I don't want to save what is already there. Jeez, this is hard to see. Okay, so I want it to be a graph, so I'm going to pick 2 for add graph. And just trying to get it so it's maybe not so horrible. There's just a terrible glare on this right now for you guys. Okay, so normally when you graph, it says f1 of x, but we want this to be polar. And so to make it polar, it does not help. Sorry, I'm playing with my projector and seeing if I can get it to not be so terrible. Okay, I need it to be polar. So what I'm going to do is I'm going to go to menu. I'm going to go to 3 for graph entry. And it's automatically in function mode. I need it to be in 5, which is polar mode. Okay, so I'm going to pick 5. When you do that, it changes it to R1 of theta. So that means it's R equals, and that's going to be in terms of theta. So I'm going to enter in this equation, cosine 2 theta. So I'm going to go get my cosine, and then 2. My theta is in the pi menu. So the pi, which is next to the letter H in that menu at the end, you see the theta. And you can leave the bottom the same. Now, I know we put our calculator in degrees, but it still shows up in radians. That's okay. Okay, that's okay. If this says radians and this says 0 to 6.28, that's 0 to 2 pi, that's okay. If this says degrees, and sometimes it will say degrees, this needs to say 0 to 360. Okay, what this means is that it's going to put a point, like it's going to calculate it for every angle, like every 1300ths. Okay, so then when we hit enter, we should get, and we do, I don't know if you can see it, we get a little rose. Oh, there, you can see it a little bit better now. So we get a rose. Okay, and if you look at it a little bit more closely, the radius is 1. Okay, the radius, how far out the petals go, is going to have to do with the number in front. So if there were a 3 in front, the radius would be, the petal length would be 3. Okay, this is 2, and notice I have 4 petals. Okay, if you have an even number, the number of petals is going to be double. If you have an odd number, like if this was a 3 or a 5, then that is the number of petals. Okay, so if it was a 3 here, I'd have 3 petals. If it was a 4 here, I'd have 8 petals. Okay, so now I want to graph this. So I'm going to hit Control T. And I'm going to look at this table. And this table is the angle measures are going up 1 degree, 2 degree, 3 degree, 4 degree, 5 degree. Well, when I look at my scale here, though it's going like 30, and then I know where the 45 is, 60, 90, and so on. I really don't want my table to be going by such a small increment. And so what I'm going to do is I'm going to go to Menu. I'm going to go to 2 for Table. And I'm going to go to 5 for Edit Table Settings. And what I want to do is I want my table still to start at 0, but I want my table step to be like maybe 15 degrees, or you could do 30. I like to do 15 so it captures like the 40, the multiples of the 45. So I do 15 and then it changes. Okay, so these are my angle measures, and then these are my radii. Okay, so I would start at 0 degrees with a radius of 1. And then I could estimate where 15 degrees is, and then 8.66, and 30 degrees is half, and 45 is 0, and so on. Now, you really kind of want to think about it as you go all the way around the circle, 0 to 360. And this is the reason we put our calculator in degrees, is so that when we look at our table, it's in degrees, right? You see how it switched to degrees here? But we should be noticing we have symmetry in our graph. And so we don't necessarily have to plot every single one of these points 0 to 360. We want to use our symmetry to make our lives a lot easier. Okay, so I'm going to start plotting these, and then I'm going to show you how you could do this if you're using decimals. All right. So I know it's hard to see it all at the same time. So you really do want to have this in front of you. So my first point is 0, 1. So 0 degrees and a radius of 1. Now I know that my petal length is 1. So I might change my scale here and say like that's 1 all the way out there, just so it's not so squished in there. So here's 0, 1. Okay, then it says 45 or 15 rather, which would be like here, and then 0.866. So I could estimate, that's 0.75. I could estimate where that is if I want. 30 is an easier one, right? That's half. And then 45 is 0. And so if you're looking at your graph here, you can kind of see that's the first half of that little petal. So I don't have to plot every single one of them. Like there, I have my first half of my petal. And so then I could keep going. Say at 60, it says negative 0.5. So that means I have to go to the other side here. And so, okay, now I'm working on a different petal. So if you wanted over here, you could say, well, I know this is going to just kind of flip around and it's going to give me this petal here. Like I said, you don't necessarily have to do every single point. Use what you know about the symmetry. Okay, I could do 75, which is here, and then do the 0.866 again. At 90, here's 90, but the radius is negative 1. That comes down here. So now you see you're getting this next petal, and I could take this and I could flip it over, and I've got that petal. All right, 105. 105, okay, that's just giving me this point. I already have that one. 120, which 120 negative 0.5, it just gave me that one. 135 is there. So here's 150. Here's 150 is at 0.5. Okay, so just even using that, you might say, okay, well, I know that's going to be 0.5, and across is going to be 1.5, and then this is going to be at 1. And then I can draw that. And then I could do the same thing for this fourth. I know this is going to be 1. I know this is going to go at a half, and then there's my petal. Okay. Otherwise, you can sit here and go through all of them. It gets really tedious, though. Okay, so that's the idea with that. Now, for this next one, let's look at that one in Desmos. Now, if you are using the Inspire, one more thing, and you wanted to do another graph, you can make a new document. What I like to do a lot of times is just keep my document and hit Control Doc, and it adds another page. Okay, so I'm going to pick Graph, It always defaults to function, you guys. Let's see if I can get that up. It defaults to function, which is a pain. So you have to go to menu, you have to go 3 to entry, you have to go -5 for polar. Yours might be different depending on which version you have. Okay, and then I enter the equation. So -2 cosine, and then theta remembers in your pi menu. And then, you see it? A little bit, there it is. It's a circle, okay? It's a circle with a diameter of 2. Okay, so that's what that number in front is telling you. The negative, it would have, if it was positive, it would have been over here. The negative flips it. Okay, let's take a look at this in decimals. All right. Oh, come on, decimals. Over here. Okay, just decimals.com. And they changed the screen. Graphing calculator. Come on. Oh, it's loading. I'm not so impatient. I'm like my own children. Okay, so we need to go to settings. So we need to hit the little wrench, and right, it's usually on rectangular. I want it to be polar. All right, so now when I come over here, I can type in R equals -2. If you're on a keyboard, you can just type cosine. If not, you can pull up this little menu if you're using the phone, and functions over here. There's cosine. The theta is you have to do the shift, like the capital ABC. And down here at the end, under the letter P, I had to search for this, is the theta. And there's the graph. Now, the thing with this, though, is it doesn't give you a table like it does if it was an XY. It doesn't give you a table. And so the way you could use this, though, would just be to look at it and say, okay, well, I've got a point at 0. Yeah, I got a point at 2, 0. And then maybe like just pick a couple, like a point, like where does this seem to be? Where does this seem? Like that seems to be what, 45, and like just eyeball it as best you can. So if you're doing homework, I think it's fine to do it like this, but on the test, you need to be able to do it with the Inspire so that you're getting that more accurate graph. So I might even change the scale here and say this is 1 and this is 2, and I know it ends at 2, but I do want to get a couple of points like over here, a little bit more accurate. So homework, yeah, I think Desmos is fine, but for like the test, for it to be more accurate, you really want to be able to do it in the calculator. Just seeing if I can get this any better so you can see it slightly. Okay, so I'm going to hit Control T to look at my table. Kind of irritating here because every time you have to go to menu, 2 for table, 5 for edit table settings. You have to change your table step every time. So I'm going to change it to 15. And then there are my points, which you guys probably can't see all that great. All right, I do, and you know how like in general when you graph, how you're like, I'm gonna look for some nice ones and then plot those. Like I see 60 and I see -1. Okay, 60, -1 would be here. Okay, it's gotta be another one over here reflected. Okay, so I might then plot, the reflected one. That gives me an idea of, a couple of points to plot, right? And then I might just, like I got 121. I already got that one. I might plot a couple of nice ones at 150 or find a couple of nice angles. 150, it's at 1.73. So it would be about here. And then I might reflect that over and say, okay, well, I know I've got a circle going through there. And then I might just draw in my circle and call it a day. That's a kind of a bit of a wobbly circle, but that would be the idea. All right, I'm not gonna go through every single one of these. We might just look at them, but we're not going to necessarily graph all of them. Just going to get real tedious. But let's at least graph number 3 together. So 1 minus 2 times the cosine of theta. That is going to be one of like these guys here. The numbers are different. So that's going to be one of these. Sometimes it has the loop. Sometimes it doesn't have the loop. And we're not going to get to the point where like you have to know when it has the loop or when it doesn't have the loop. So I'm going to add a page, I'm going to add a graph, I wish my calculator didn't have such a stinky glare on it. Then I would type in the 1 minus 2 cosine theta. Oh, cosine, and I picked sine, darn it. Cosine theta. All right. Where are you? Oh, you guys, I didn't change it. All right, menu 3, 5. Now let's try it. I was like, where is it? Helps to change it to polar mode. Okay. All right, so there we see we have this guy with the loop. All right, if you put your grabber hand on there, and you hit control, and at the same time as you hit control, you hit this middle button, and then release, you can move it and drop it. Okay, so some things that we want to notice about this is that it goes out to 3, right? Kind of the length of it is 3. That comes from the numbers 1 and 2. If you take the absolute value of those numbers there and add them together, that would kind of be like the length of it, right? Because it's a cosine, it's horizontally oriented, right? If this had been plus, it would have been on the other side. It would have been sine, it would have been turned the other way, okay? And so we're going to go to the table here in a minute and look at it. I just want to show you also what it would, how we would look at it if we were in decimals. So we would have r equals 1 minus, and then again, oh, I didn't want to do that. My functions here. 1 minus, oh, I was supposed to have a 2 in front, dang it, 2. Then functions, cosine, and then the theta. So I have to go to the ABC menu, and then here's my theta, and there it is. Okay, so this one you can kind of on the screen see it a little bit better. So you can see it goes out to the 3. You can see the loop. Again, if I were maybe graphing this and I didn't have the Inspire, I might look at this and say it's a 2/3. Right, that 120 looks to be at 2, and then I could plot the point under it, and then I might look at 5 pi over 6 and see where that is, and just use like maybe a handful of those points. You might notice the loop's at 1. Okay, so those things will be helpful as you're going to actually graph it if you're using decimals. So you might, I mean, the decimals is really easy. It's clear to see it. All right, I'm going to go back to this Inspire. So again, I'm going to hit Control T. I'm going to look at my table. And I've got 3 in here now, so this isn't going to screw me up too badly with my table. Okay, I need to go to, again, menu, table, 5 for table set, and change my table step to 15, and then I can see it all a little bit better. And here's, I want, for me, it's my 3rd column here. All right, so at 0, I'm at 1, or -1, sorry, here. So that's like, I know that's part of my loop, right? And I know this goes out 3. Okay, so I can kind of start getting some points that are going to be on there. 15, it says -9.330. It says like -0.73. So it's like here, it's like here. So it's like my loop, okay? It doesn't have to be perfect, but there's my loop that you can see. 60, it's at 0. Okay, that's finishing my loop. At 90, I'm at 1. Okay, so at 90, I'm at 1. So that means I'm coming out of my loop. And then I know I would also down here at 270 to have another 1, right? So I can kind of do that symmetry while I'm going. 105, that'd be here. I could do one of those. I'm going to skip to the 120. 120 is at 2. So 120 is at 2. Okay, so I can see myself now coming out of the loop. Okay, then I could reflect that down here. Okay, and come out of the loop here. So I can just do that a little at a time. Like I said, I don't have to do every point. I might see at 150 was at 2.73, so about here, and then I would reflect it over, and then I would finish it off. Okay, so again, you don't have to plot every single point. We want to kind of get the big idea. All right, r sine of theta, if I were to graph that one, and let's just take a look at a couple of these graphs in decimals just to see what they look like. R sine of theta, that's going to be, my kids are yelling, a circle, radius 1. Okay, if I type in the next one, 2 minus 3 sine of theta, okay, you can see that that's another one to skip, but the sine is making it vertical. If we add the 2 and the 3, we get the 5. Can you hear my kids? And the last one is, this is the spiral of Archimedes. And it just is like if it was 1 degree, 1 radian, a radius of 1 degree of 1, 2, 3, and so on. And so it gives you this spiral. All right, so that takes care of section 2.